Hi, class. I'm going to read this book to you today called Do You Really Want to Burn Your Toast? A book about heat. So, remember the last time we were working in science, we had made a hat that could block the sun, and we were thinking about the properties of the materials that we were using. And we chose materials for our hat based on their properties. For example, most of us choose paper towels because of their property that made them absorbent. They would absorb our sweat if we got too hot. We also chose paper plates because the brim was stiff, and that stiff property kept the hat away from our head and it kept our faces shaded. So, today we're going to be talking about some properties again in this book called Do You Really Want to Burn Your Toast? I am going to flip to the back of the book right now. Usually we start right at the beginning, but I do want to flip to the back because this book has a glossary. And I want us to make sure we know what some of these great words mean when we're reading the story. So the first word in our glossary is the word conductor. And I can think about that word conductor like, oh, and you might be thinking about trains right now. You know that word conductor because you're a train expert. But in this book, the word conductor is used a different way. Let's see what it says. Conductor. A material that lets heat transfer through easily. Metal is a good conductor. So if you think about something like a metal pot on the stove, as the water or the soup or whatever you're cooking in the pot gets hot, the metal pot gets hot also. That means it's a good conductor. The heat can go right through it. That's why you wouldn't touch a pot that's on the stove, because not only is the stuff inside hot, but the pot itself is hot too. So that's what they mean when they talk about a conductor. It means heat can transfer through it or go right through it easily. We know what it means when something gets cool, when it cools off, like the heat starts going away from something that's warm and it gets cooler. Electricity, a form of energy that's generated at large power plants and flows through wires. We know heat. Heat is the transfer of energy from one place to another due to the temperature difference between the objects or places. Another big word for us to think about today is insulator. An insulator is the opposite of a conductor. An insulator is a material that blocks most heat transfer. Plastic, wood, and cloth are good insulators. So if I'm thinking about the pot and how the pot gets hot, let's say I wanted to pick it up. Then I'd use something like a pot holder. A pot holder would be a really good insulator because the heat wouldn't go through it. The pot holder blocks the heat and then my hand won't get burned. And then the last word in our glossary is temperature. So how warm or how cold something is. We're going to see all of those words as we read our book today. The two big ones we really want to think about are conductor and insulator. A conductor passes the heat really easily, and the insulator blocks the heat. Here is our story. Do you really want to burn your toast? A book about heat. Jaden, let's make breakfast for Mom and Dad. Shh! Lexi, they're not up yet. Let's surprise them. I'll make toast. I'll make muffins. To do all this cooking, you'll need heat. But what is heat exactly? Heat is when energy is transferred from one thing to another. A toaster uses electricity to make heat. When you put bread in a toaster, energy is transferred to the wires inside. Heat from the wires toasts the bread. Jaden, come back. Do you want to burn the toast? Oh no, Lexi. The toast is burned. We can't serve this. Oops, that was too much heat. Heat can change things. Some changes, like when toast burns, can't be changed back. Jaden, help me with the muffins. I need 2 eggs. Don't forget to turn on the oven. The box says to set the oven to 350 degrees Fahrenheit or 177 degrees Celsius. These numbers measure the temperature, which tells how hot or cold something is. The higher the number, the hotter the temperature is. What will happen in the oven? In the oven, the heat goes all the way around the muffin tin. But it doesn't just cook the tops of the muffins. Metal is a good conductor. That means it lets heat transfer through it, so the muffins will cook on the bottom and sides too. Oh, so that's why so many of the things we put in the oven are metal, so the heat doesn't just touch the top, it touches all of what we are cooking. As the batter bakes, the heat changes it into soft, fluffy muffins. You can't change them back into eggs, milk, flour, and baking soda, but the muffins smell delicious. Be careful when you take muffins out of the oven. The pan will be hot. Use oven mitts to protect your hands. The oven mitts act as insulators. They don't transfer heat very well. What happens when you put the warm muffins on the counter? Heat always transfers from warmer things to cooler things. So the heat leaves the muffins and warms the cooler air around it. If you take cold butter out of the fridge, it will warm up. This happens because the warmer air transfers energy to the cold butter. Lexi, it's sunny this morning. Let's go play outside while we wait for Mom and Dad to wake up. The sun gives off heat too. Energy from the sun travels all the way to Earth and heats the surface, making it just the right temperature for us to live here. Oh no! Max ate all the muffins and the butter melted. Now what? The butter is still butter. It will change back into a solid when it cools. And we could cook some eggs. Maybe I can make toast without burning it this time. So the change that the butter had when it melted can be changed back. If they put that butter in the fridge, it will harden again. It will still be butter. I don't think those muffins will ever be muffins again after the dog eats them, though. Good morning, Mom and Dad. We made breakfast for you. Thanks, kids. And then in the back of the book, they give you some examples for experiments with heat that you could try at home if you wanted to. They have an example for solar cooked s'mores, and they give you all the materials that you need and give you directions for what you could do. They also give you directions for this magic dancing coin experiment that you could try. And they tell you the materials you need and everything that you need to do. This book is on Epic. So if you go to Epic and you search for, do you really want to burn your toast? You could see these experiments and try them out at home. And then remember, our back of the book has some great glossary words for us to know and remember. And it also gives you some websites if you're interested in exploring more about heat. I hope you enjoyed the book, and we will use what we learned in this book in science tomorrow.